Yeah, okay. Well, I think we can start. Ladies and gentlemen, welcome to this webinar live session from Balingen. Hello, all over the world. My name is Oswald Horner. I am development engineer here at Wenzel Company, and I proudly present you our newest sensation in 3D roughness scanning, our new sensor WMRSC. Well, why roughness? Well, roughness gains importance in most fields of quality assurance, and you can realize when you take some technical drawings. Meanwhile, you find information on RA, RZ, RP, RQ on nearly every technical drawing, and it is part of the geometric product specification and has also some heuristical components. So those parameters are very often even binding parameters. So in general, you can say that roughness has become even a quality criterion, not only in the roughness world, but also in the CMM world. And this is a need why we have to consider the roughness in general. Well, within the roughness environment, the optic gains importance due to two reasons. One main reason, the non-destructive measurement principle. You do not destroy your surface like you see on the right-hand side. Here you can see you can measure a whole surface without destroying the surface with any kind of stylus tip, for example. And the second reason is that you can do better statistics about the surface since you get simply more measurement point and an area scan. So these are the two main reasons why to consider optical measurement in general. And one more reason is that the roughness standardization is a very dynamic process. It becomes more and more applicable even in the roughness world and in the CMM world. And so we considered to develop our own sensor. The point is that Wenzel Company so far didn't deal with roughness that much. Wenzel has been focusing on the CMM world and so on the micron. But if you need to consider roughness, you have to consider the nanometer as well. And well, this makes sense since you get higher demands, you have decreasing tolerances, and so you can say in general that the micron isn't enough anymore. And so there were a few developers at Wenzel Company from several departments that came together. We discussed this, we talked about that we are good developers in optics, we know software, and we were extremely motivated and so started to develop our own sensor, the WMRSC, that is redefining our measurement scale here at Wenzel Company. And this sensor, I have it here, I show it directly now, is a very small sensor you can see that has some really interesting features and technical information, and I want to show you those. Well, the WMRSC is a coherence scanning system, which means generally spoken a white light interferometer that measures 3D surfaces. This sensor combines the extreme vertical resolution that you might know from competitive systems with an extreme high lateral resolution. This is possible since we use a full HD camera chip within this sensor, which enables us to measure more than 4.1 million triangles per scan, of course, with an optional region of interest. The vertical resolution is less than 5 nanometers. This is a rough approximation since we know that the light interacts with surfaces. So we have, for example, some oxide layers that might influence your topography when measuring. So, but we can say we are lower than 5 nanometers, and our lateral resolution is about 55 nanometers if you need use a lens with magnification of 100x. Our lenses, they are Mirau lenses, meaning you have a beam splitter and an optical mirror integrated in your optics. So this is a very compact design. This means even that your sensor gets really, really tiny. You can change your objective, your lens very easily. You just take an RMS thread and you adapt or attach your lens within seconds. Well, the sensor itself, I think it's well, one of the smallest sensors on the market, probably the smallest sensor of its class, and it has some more interesting features. For example, you can adapt the sensor to our Wenzel core machine, which is a 5-axis machine, so measuring at the machine directly. I will tell you something about this later. And you combine the sensor also with our scalable nano measurement station. You get some information about this too. And therefore, we use a Wenzel interface, which is just plug and play, so you can adapt it to your machine and it works directly. One more feature is it is fully integrated in our WM Pointmaster software, a really powerful software. And of course, we are going DIN and ISO conform, meaning we consider the DIN and ISO 4287, 1660, 601, and 135065. So how looks such a measuring task? Well, a measuring task looks this way. You scan a vertical range, you take an image stack, and this image stack is evaluated, meaning you are measuring per pixel a parallelogram that has it's containing all the height information, and have shown here on the right-hand side one picture, one image of this image stack, for example, measured on a groove of silicon or on a turned surface made of steel, or for example, on a grinded surface made of aluminium. So in general, you see there are several and multiple kinds of surfaces that you are able to measure. The intermediate result, and I call it intermediate result because this is not the end of your evaluation, is the topographies that you measure that you can compute into an STL mesh or into a point cloud. And here the dimensions are about 530 x 300 microns if you're considering to use a 20x lens. Well, the sensor, the WRM RSC, has been optimized to measure a variety of technical surface types. So, I mean, it's very flexible, robust, and easy to use. And on the right-hand side of this slide, you can see several surfaces that have been measured with this microscope. Yeah, I start in the left corner. There you can see a photosensitive detector, a CMOS sensor, and due to the very high lateral and vertical resolution, you can see all the structures upon the surface. So generally spoken, this means that you can use the sensor, for example, for semiconductor industries, chip industries, or if you want to analyze even microstructures. Other applications come from medical products. So it's, for example, hip joints here or implants, or from the standardization field. So if you have scientific application, you can use this sensor as a lab sensor as well. So a very interesting application too. And of course, even in the automotive industries, if you want to measure, for example, function-oriented surfaces such as cylinder barrels, where you have those surfaces, those structured surfaces that have a certain reason, for example, to have some oil film upon the surface. Well, I already mentioned it that you can adapt the sensor due to its new Wenzel interface directly to our new nano measurement working place. We call it standalone because you do not need any kind of machine for using it. You just put this in your lab or in your measuring environment to adapt your sensor, and you can also place big parts upon the upon this standalone solution. So meaning you are very flexible, for example, to measure motor blocks or any kind of cylinder heads, for example. This machine is scalable upon limits about 2 meters, so you can even measure very big parts upon it. So every sensor is only as good as the software it's working with, and the WMRSC sensor is a perfect partner of our powerful Pointmaster software. Therefore, for using it, we implemented a roughness module and a sensor interface, so you can directly acquire all those images, all the data directly in this software, convert it, and you get directly your surfaces for your analysis. And due to our new roughness module, you can also do all the evaluation directly in the software. And I have an example here on the right-hand side. So this is once again our microstructure with extreme lateral resolution. This is only one scan, not stitched, one scan. And yeah, if I go to the detail, you can see how big this resolution actually is. Yeah, I mean, you can do any kind of surface extraction. You can use fitting algorithms on your STL mesh. You can do some CAD comparison, whatever you want. So meaning it is a very, very powerful tool. But of course, this is not the only thing. You can do the roughness evaluation as well. So you see this little profile drawn in here. This is drawn with a virtual stylus tip upon the mesh, and this enables to do our isoconform roughness evaluation. And of course, you can also use all the powerful tools that you already know from the PointMaster software, for example, fitting algorithms or surface extraction algorithm. And here I have an example. Just we fitted some spheres upon the surface that I showed you here, and you see the dimensions. The distance is approximately 800 nanometers, which is extremely small. Yeah? So you see, a very, very powerful tool. But I think in the most cases, if you're interested in measuring roughness, you are just interested in getting a roughness protocol. So you can do this in the PointMaster software as well. You define your profile, you get your virtual stylus tip, you do some filtering, so extracting the primary profile, the waviness profile, the arc profile separately. You can choose whatever you want. You can get your parameters, so the R, the P, or the W parameters, and you can also do the Abbott curve evaluation, so meaning considering the material ratio. And of course, you're open to export and draw your mesh on Point Cloud as well. And if you are not interested in the roughness at all, but in features of your surface, for example, segmentation, you're free to do this too. So, for example, shown here, a watershed segmentation of your surface, just to get an idea about the height of your features upon your 3D surface. So we have been considering the micro world at this point, but most times you are not interested in the micro world alone, but you're interested in the microscopic world too, because we all know that those are not separate worlds. We try to separate them, but they belong together. And that's exactly what we do with our solution, the combination of PointMaster and the RSC. We bring those both worlds together. And you can see it in a little example. This is a turbine plate that has been measured. And when we go into detail, at some point we get our roughness evaluation. At some point we switch in our roughness module and then get a detailed description and an idea about how our surface looks on the micro scale. So, and of course, we are free to do all the evaluations that we know from the DIN and ISO standard. For example, we can even draw profiles that are not linear, meaning a meander structure or a spline structure, for example, to increase your length of your evaluation length. Yeah, of course, I know this is only allowed on isotropic surfaces. This was not an isotropic surface, but it should give you a clue about what we are able to do. So, and now I come here finally to our highlight about our sensor, because we were considering what is the difference between Wenzel and other competitors. And I considered three cases. The first case is the simplest case. You take a sensor, you put it on your table, you measure directly the surface, you get maybe some protocols on report about your parts that you have been measuring, and you are finished. That's the simplest way. So more advanced way is to do a 2.5 analysis in some kind of CMM system, meaning you have, for example, a table that you can move, you can do some stitching, you can increase your measurement range, and that's what the most people actually do, what competitors are doing. But the problem is you still do not really know what's going on on the microscopic scale. Yeah, you know what your surface is looking like at some certain point, but it will be hard to find this position, for example, that you are measuring once again. And that's the reason why we decided to go the third way, to measure in a workpiece system. So meaning you are describing your workpiece within a machine system, in a CMM, and then you are free, for example, to use multi-sensor applications as well. And this is the king, the supreme discipline, or we call it the Mansell discipline. And yeah, this is really cool. And yeah, you can do plenty of things with this option. And this is the most important thing. You can do it on the machine while using the machine. What does this mean? Well, usually if you have some coherent scanning system, some white light interferometer, you have always problems with vibrations, because evaluation algorithms, it's hard for them to handle those vibrations since you want to measure on the nanoscale. Yeah, but we have developed powerful and highly parallelized algorithms that can also handle those vibrations on unstable systems. So oscillations, shocks, vibrations, movements or regulation deviations that might result from a shop floor environment, for example, that do not affect our results. We are still able to measure with our sensor with a full natural resolution on those systems. And we have proved this, and we can do this, e.g. on our 5-axis core machine that comes from Mansell in trading. And here we have some example of such measured surface, a whole surface that we measured there. So yeah, you see here an application for our powerful analysis on our CMM. So yeah, this was, I hope you got an impression about what we're able to do with our new 3D roughness sensor. And so now there follows a short conclusion about why you should buy our product and even other products, and why this is so interesting. Well, you know, Mansell has been building CMMs for more than 15 years so far. And yeah, so most customers, they capitalize from the huge Mansell product diversity. So you have a sensor for each task. Here we have very good employees that can help to help you with any kind of tasks that you have, that you need to solve. And so we can also satisfy our customers because we can prove that we protect to invest in our products and even in the future. And the reason why you can do this is because we provide a one-hand solution, and we use a common software basis for our development. Yeah, well, CMMs is keeping our core business, of course, and our strengths, and we make it better. We combine it with the micro world, so extending our measurement range and decreasing the limits in our scale. So with this slide, I want to end my talk. I hope you enjoyed, and yeah, hopefully you find other interesting products on our online expo. I think the chat room is open for discussions. Meanwhile, it's 6 o'clock, now 6:20 now here in Germany. So just in case it's getting too late, I will answer any kind of email as well. So you can simply write, and we will, hopefully help you with your ideas, your problems, and we're looking forward to hear from you. Thank you.